Okay, so the beginning of 9.6 is going to be these exponential equations where the x is in the exponent. And that's what you're solving for. So there's two different methods depending on whether or not you can do method 1 or not. On number 1, you have 3 to the x power equals 243. So the first method that you're checking for is to see if you can rewrite this side to have the same base as this side. So can I rewrite 243 as 3 to a power? So let's look, let's see. What is 3 to the first is 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth, so again, multiply this one times 3 again would be 81. And 3 to the fifth, which means if I multiply this times 3 again, is 243. Which means I can rewrite this 243 as 3 to the fifth power. Okay, so that's exactly what I'm going to do. I have 3 to the x equals 3 to the fifth. So that's the first method. If you can rewrite the other side to have the same base as this one, that's what you do. And then all you have to do is set up your exponents as your equation and solve for x, right? Because what does this need to be if these are going to be the same? 5. So just set up your exponents as your equation and solve. Right, number 2, let's see if we can do the same method. 4 to the 4x equals 64. So let's see if we can rewrite the right side as 4 to a power. So let's see, 4 to the first is 4. 4 squared is 16. 4 to the third power is 64. So I'm going to rewrite this 64 as 4 to the third. So let's see, I have 4 to the 4x is 4 to the third. So if I make my bases the same, then I just set up an equation with my exponents. So I have 4x equals 3. Now on the last one, I was already done because I just had x equals 5. X was solved for. This one, I'm just solving like I would any other equation by dividing both sides by 4. So x equals 3/4. Right, number 3, 2 to the x equals 19. All right, so I'm going to have another method here, right? Because I cannot, so 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And then 2 to the fifth is 32. So I passed right over 19. So I have to have another method. Now, this is going to have to do with those properties of logarithms. If you have a log and that log has an exponent, how can you rewrite it? You can rewrite it by bringing that exponent down and be times the log. Remember, we did a lot of that on Friday. We always brought down our exponents. So what I'm going to do is, remember, I can do absolutely anything I want to an equation as long as I do it to both sides. So what I'm going to do is I'm just going to log both sides. because now I can use that property that says, well, if this is a log and it's got an exponent, I can bring down that exponent. So I have x times log 2 equals log 19. Solving for this x that's now not in the exponent, I just need to get rid of that times log 2, so I'll just divide by log 2. So x equals, and then you'll just punch this in your calculator, and it's going to give me a decimal. Where is this number going to be in between? It's going to be in between 4 and 5, right? Because 19 is right there. So 2 to what power is 19? It's going to be really, so it should be close to 4. So let's see, just punching that in your calculator. Log 19, close it, divided by log 2. Oops. Okay, so you're just doing log 19 divided by log 2, enter, and there's your answer, round it to 4 decimals. And it is close to 4. It's 4.2479. After the 9 is a 2, which just tells me I don't need to round up. Right, number 4. All right, let's see. First of all, if we could use method 1. So since it's 2's, I just left those up there. Can this 16 be written as 2 to a power? Yeah. Can be rewritten as 2 to the 4th power. So that's what I'm going to do, because if you can do that, that's an easier method to use. So I have 2 to the 6x minus 1 equals 2 to the 4th. So since I can make my bases the same, then all I have to do is set up an equation with my exponents. So 6x minus 1 equals 4, and then solve it for the x. So add the 1 to both sides. So 6x equals 5, and divide by 6. So x equals 5/6. Number 5, 2 to the x power equals 6. So I cannot rewrite 6 as 2 to a power. It's in here somewhere, which means my answer is going to be between 2 and 3. Okay, but how do I get that x out of the exponent? I'll log both sides. And then I'll use that log property that says I can bring down the exponent. So I'm going to have x log 2 equals log 6. Get that x by itself by dividing both sides by log 2. So x equals, put that in your calculator. So log 6, close, divided by log 2, close. There's your answer. The original problem is 2 to the x equals 6. So since I couldn't rewrite 6, right, as 2 to a power, that's why I logged both sides to bring down that x. So, and then round it to 4 decimals. So x equals 5, 8, 4, 9. After the 9 is a 6. So I am rounding up. So this 9 rounds up to 10, which just means this rounds up to 5, 8, 5, 0. Number 6. (10 to the negative x) equals 2 to the 6x. So I am going to have to use the log method to get those x's out of the exponent. So I'm going to log both sides. Then I'm going to use the property that says now I can bring my exponents down. So I've got negative x log 10 equals 6x log 2. So now I'm in a situation where I'm solving for x. However, the x's are in 2 different terms, and those terms are not like terms, so I can't put them together. Okay. However, if you do have an x, it's in 2 separate terms. You do want those terms to be on the same side as each other, because if, say, I move this one over here and put it on the same side as this, it's going to be x in common with those 2 terms, and I'll be able to pull it out. Okay. So again, x is in 2 terms. You just want to put the terms on the same side as each other. So I'm going to add x log 10 to both sides. So now I have 0 equals 6x log 2 plus x log 10. So here's what I was talking about. X is in common with both of these terms. So it's the common factor, and I can pull it out. So if I pull out the x, put in parentheses what's left. So if I took the x out of this first term, I have 6 log 2 plus, if I took the x out of this term, I just have log 10. I have 0 on the left. So here's the x that I'm solving for. I can get rid of all this in one step, right? Because it's x times all that, so just divide by it. But look at what this other side is. Zero, which means I'm not even going to waste time punching this in my calculator, because 0 over anything is just 0. Doesn't matter what your denominator is. If your numerator is 0, it's 0. Number 7. E to the t power equals 629. And I'm solving this for t. T is in the exponent. So instead of logging both sides, since I'm dealing with an e, and you'll see why on this next step, I'm going to use ln, the natural log of both sides. It has those same properties as logs, so I'm still going to be able to bring down this t. So I've got t times ln e equals ln 629. Now, here's why I used ln. Anytime I'm dealing with e, I want to use an ln because what is ln? It's log with a base of what? E. So if this is log base e of e, what is this equal to? 1. Remember, this right here, if these two things are the same, this whole thing is 1 because what does this mean? E to what power is e? The first. So anytime these two things are the same, this whole thing is just a 1. So this really says t times 1, which is just what? T. So anytime you see that ln of e, it just kind of goes away because it's just a 1. So now I have t equals ln of 629, and I just punch that in my calculator. Hit your ln button, 629, close, and then round it to 4. 6.4441 after 1 is a 3, which means you don't need to round up the 1. Number 8, similar. E to the negative 0.15t equals 0.43. So I'm dealing with e, and I want to get this t out of the exponent. So that's going to ln both sides. That helps me bring down the exponent. So now I have negative 0.15t times ln of e equals ln 0.43. But again, what is this? 1. So I just don't even need it. Right? Because negative 0.15t times 1 is just negative 0.15t. So if I'm solving for t, what do I need to do? Divide by negative 0.15 to get that t by itself. So you'll just put this in your calculator. ln 0.43, close. Divide that by negative 0.15, and then round it to 4 decimals. So 5.6264. After the 4 is a 6, so I do need to round this one up. 6265. All right, number 9. Number 9 will be our last exponential equation, and then we'll move to logs. (15 to the x equals 5 to the x plus 2. I'm not dealing with e. The x's that I'm solving for are in the exponents, which means to get them down, I'll log both sides. On this side, I'll bring down my x. So I have x times log 15 equals, bring down the x plus 2, log 5. Now, be careful on this right side. This right here needs parentheses around it because you're not just doing 2 log 5, which is what that says. You're doing x plus 2 log 5. So I actually need to distribute this log 5 to both of those. So let's see, x times log 5 is x log 5 plus 2 times log 5 gives me 2 log 5. I'll just bring this side down. X log 15. Now, again, just like a few problems ago, I'm solving for x. It's in 2 separate terms, which means I need to put them on the same side as each other so that I can have an x in common and pull it out. So I'm going to move this x log 5 over here, which means I need to subtract log 5, x log 5. So on the left, I've got x log 15 minus x log 5 equals 2 log 5. So here's my x in common. So I'll pull it out. Put in parentheses what's left after you take the x out of both of those. So I'll have log 15 minus log 5, right? Because I took the x out of both of them. Bring down the 2 log 5. So in order for the x to be by itself, I just need to divide by this whole thing right here. So I'm dividing by log 15 minus log 5 to cancel this. So once I do that, my x will be by itself. Now, this is tricky to put in the calculator. Okay, after you hit your log button, it automatically gives you an open parenthesis. So you'll need to make sure you close that before you go to the denominator. Now, to include all this in your denominator, instead of just this first part, you need to start off with an open parenthesis. So that's going to make sure all that is in your denominator. Now, again, just like up here, every time you hit the log button, it's going to give you an open. So you'll need to make sure you close that. Minus log, it's going to give you an open. You're going to make sure you need to close that one. So you're actually going to have 2 closing parentheses after that 5 to close the denominator and to close that log 5. So 2 log 5 close. So there's your numerator. Then divided by. So, whoops, that's not divided. Divided by. Now, when you start your denominator, you need an open parentheses. Log 15 close minus log 5. Close the log and close the denominator. Enter. And then round it to 4. So I'm going to have 2.9299. After the 9 is a 4, so you do not need to round that up. Number 10. Moving into logarithmic equations. All right, log base 6 of x equals 2. Here's how we like to see them, because if you just have one log in your equation, just turn it into an exponential equation. Just like, remember how we were going back and forth between log equations and exponential equations? What is the base of the log? 6. That's also the base of the exponent. Remember, we just kind of made this cycle right here, turning it into exponential. 6 squared equals what's in this position, which is just an x. And what is 6 squared? 36 equals x. So it's really nice if you just have one log. Then you'll just turn it into exponential by raising this is the base to this power and make it equal to what's in this position. Same thing in number 11. Log of x equals -1. So I only have one logarithm again, which means I want to turn it into an exponential equation. If you don't see the base of your log, what is it automatically? 10. So this is going to say 10 to the -1 equals x. You can just punch that in your calculator. 10, go up in your exponent, put -1 in your exponent, enter. And it tells you 0.1, which this will actually let you, it doesn't say to enter it as a fraction. So it'll let you enter it like that. If you did enter it as a fraction, what would this be? 1/10. So either one of these will be fine. Number 12. Log base 5 of 4x minus 4 equals 4. So again, one log. So I'm going to use the same method I've been using. So it's going to be 5 to the 4th power is equal to what's in that position, which is 4x minus 4. And then solve it for x. 5 to the 4th power means 5 times 5 times 5 times 5, which is 625 equals 4x minus 4. And solve it for x. So add the 4. So 629 equals 4x divided by 4. So x equals, for some reason, this one, I mean, it should take this answer, but I'm looking at the answer sheet and it's saying a decimal, which would just come from dividing 629 divided by 4, which gives you 157.25. This one has more than one log. All right, number 13. This one has two logs, but they have the same base, which means I can rewrite that as one logarithm. Okay, remember if I rewrite this as one log and it's plus, what can it be? Log x times x plus 48. Remember that from that last section, rewriting it, simplifying it into one log. Plus turns into multiplying this. If this was a minus, I would put the x over the x plus 48. We're going back to those rules. So since it's plus, it's going to be log x times x plus 48 equals 2. So now the reason I did that is because now I do just have one log. So do like what we've been doing. I don't see the base, which means it's 10. So how do I write this? 10 squared equals what's in this position, which is x times x plus 48. Solving for x, 10 squared is 100. Equals, distribute this x. X times x gives me x squared plus x times 48 is 48x. What do you have when you're solving an equation and it's x squared? Quad. Now, before I can go to my quad program, this side has to equal 0. I need to move the 100 over there, which is important because if you're using your quad program, what's happening to the sign when you move it across the equal sign? It's changing from positive 100 to negative 100, right? So I have x squared plus 48x minus 100. So I can put that in quad. If I put it in quad, A, B, and C are 1, 48, and negative 100. Okay, if I didn't have quad, I could factor this. X and x for x squared. Factors of negative 100 that add to 48 are a positive 50 and a negative 2. Set these equal to 0 and solve them, which would give negative 50 and positive 2 as my answers, but only one of them is going to work. Because think about this. If you put this answer and you plugged it in here for this x, what happens if you type in log of negative 50? It's going to give you a non-real answer, right? So this negative answer is not a true solution, just the 2 is. Log base 4 of c plus 16 minus log base 4 of c plus 7 equals log base 4 of c. Logs everywhere. So the first thing I'm going to do is rewrite the left side as one logarithm. They're both log base 4. This one's minus, which means when I rewrite it as a single log base 4, it's going to be c plus 16 over c plus 7. Just bring this side down. So this one's different than the last one. At this point on the last one, I didn't have a log over here. But look, you've got log base 4 on both sides. I can do anything I want as long as I do it to both sides. So why not just divide both sides by log base 4? I'll just cancel them out. So now I just have C plus 16 over C plus 7 equals C. Solving for C. I have a C in my denominator on this side. So here's what I can do to fix that. Multiply both sides by C plus 7. Because look what happens on the left. Cancels. So you're just left with C plus 16 equals, on the right, distribute your C. So C squared plus 7C. So again, it's quad. So you want to set this side equal to 0. So move those terms over here. So you need to subtract C and subtract 16. So 0 equals C squared. 7C minus 1C gives me plus 6C minus 16. So you can either put that in your quad or factor it. C and C for C squared. Factors of negative 16 that add to positive 8 are a positive 8 and negative 2. Set it equal to 0 and solve them. So this would end up being negative 8 and this would end up being positive 2. I can't put a negative 8 in for this C because I have negative 8 plus 7, which is negative 1, which gives that an error. So that one's not true, just the 2 is. Three more. (16) log base 3 of x plus 1 minus log base 3 of x equals 3. So I'm going to start off the same. I'm going to rewrite this left side as one logarithm. So since it's minus, it's going to turn into x plus 1 over x. I've got log base 3 of x plus 1 over x equals 3. So this one doesn't have logs on both sides. I'm not canceling them off. I'm going back to that other method. So since there is just one logarithm, turn it into exponential. So I've got 3 to the 3rd power equals what's in this position, which is x plus 1 over x. 3 to the 3rd is 27 equals x plus 1 over x. Which means, what do I need to multiply both sides to get rid of this denominator? X. That'll move that, that'll get rid of the denominator of x. So on the left, I've got 27x. On the right, since those x's cancel, I just have x plus 1. Solving for x. So I'll subtract the x's from both sides. 27 minus 1 gives me 26x. equals 1. And divide by 26. So x equals 1 over 26. $16. ln x plus ln x minus 1 equals ln 2. So on the left, rewrite it to write it as 1 ln. Since it's plus, these are going to turn into times. So ln of x times x minus 1 equals ln of 2. Do I still have ln's on both sides? I do, which means I just want to cancel them. So just divide them off and solve for x. You'll distribute this x. So x times x gives me x squared minus x times 1 is x equals 2. Quad. So move the 2 over. So subtract 2 from both sides. So there's your 0. On the left, you've got x squared minus x minus 2. So once again, you can either go put that in quad or factor it. X and x for x squared. Numbers that multiply to give me -2 and add to give me -1 are a -2 and a +1. So the solution here would be 2. Here would be -1. So I just need to make sure that I don't make an error by putting in a -1 here. So that's not a true solution, just the 2 is. Last one. Log base 3 of x plus 4 plus log base 3 of x minus 4 equals 2, right? I'm going to pause for a second. Okay, so finishing this one up. First things first is I'm going to rewrite this left side as a single logarithm. Since it's plus, it's going to be x plus 4 times x minus 4. So log base 3 x plus 4 times x minus 4 equals 2. So I do just have one logarithm in the whole equation, which means turn it exponential. 3 to the second equals all of this. X plus 4x minus 4. So on the left, 3 squared is 9. On the right, multiply. X times x gives me x squared. Look what happens to your outers and inners. What's outside? -4x. What's inside? +4x. So they just what? Cancel. So I'll just jump straight to my last. +4 times -4 is -16. It is quad, which just means I need to move the 9 over. So subtract the 9 from both sides. So 0 equals x squared minus 25. So either put that in quad or this is not a bad factoring, right? It's difference of perfect squares. So if I factor that, I'm going to have x and x for x squared plus and minus what? 5. So this solution would be negative 5. This solution would be positive 5. The negative 5 doesn't work. So just the positive 5.